Vertical and horizontal asymptotes. The function c equals 5,000 over n is a reciprocal function. A reciprocal function has the equation in the form of f of x equals 1 over a to a of x, where a of x is a linear function, and a of x does not equal 0. So let's look at one of the more simpler of this reciprocal functions, f of x equals 1 over x. And let's explore what that looks like with the t-chart. So you can see on the t-chart I've got -3, -2, -1, and so on. So I will first replace the x with -3. So that would be 1 over -3, which would be -1/3. And then when you replace that with -2, you get -1/2. And when you replace it with -1, you get 1 divided by -1, which is -1. But then when you try to replace that with 0, what happens when you try to take 1 divided by 0? Well, you simply can't do that. It is not possible because you can't divide by 0. So we have an interesting graph here. Let's go ahead and finish it up with the rest of the whole numbers below that, though. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. And then 1 divided by 3 is 1/3. So let's graph those. So we'll have -3, -1/3. So -3, -1/3 is about right here. -2, -1/2 is not too far over, not too far below that. -1, -1 is right there. And then I said that 0 cannot be used for x, so we wouldn't have anything at 0, 0. Then we would have 1, 1, 2, 1/2, and 3, 1/3. And that really doesn't give me a very good indication what the graph looks like. So let's go further a little bit. Let's start plugging in some of those fractions below. So if we were to take 1 divided by 1/2. 1 divided by 1/2 is the whole number 2. And 1 divided by 1/4 is the whole number 4. 1 divided by -1/4 would be -4. And 1 divided by -1/2 would be the integer -2. So let me graph those. So 1/2, 2 is about here. 1/4, 4 is up here. And then -1/2, -2 is about right here. And -1/2, -4 is about right here. And notice that I keep getting closer and closer to the axes, but I actually never touch them. And I can't touch them because first, I can't touch the y-axis because the x value can never equal 0. And I can't touch the x-axis because there's no number I can plug in for x to expect the y value to equal to 0. So I get a graph that is split up like this, where I cannot touch those axes. So some key characteristics of this. The type of graph is called a hyperbola. Hyperbola is how you pronounce it. And the basic parent function of 1 over x, the domain and the range is x cannot equal 0 and y cannot equal 0. And that's before any shifting. And then it has asymptotes. And if you recall from chapter 6, the asymptotes are those lines that the graph cannot touch as it approaches infinity and negative infinity. Notice that the graph up here has no intercepts. So the parent function has no intercepts, and it is not defined. It is undefined at x equal to 0 because x cannot equal 0. So what we're going to do in this section is start to explore these reciprocal functions and what the graphs look like and how they are shifted and various uses for those graphs. So we'll start out by talking about the limitations on the domain. Example 1 says, determine the value of x for which f of x equals 3 over 2x plus 5 is not defined. Well, you cannot divide by 0. So any values of x that makes the denominator equal to 0 is going to make it undefined. So therefore, we are going to figure out what those are by setting 2x plus 5 equal to 0, and then solve for x. So we're just setting the denominator equal to 0, and by doing so, it will tell us what x would be that would make the denominator equal to 0. So x equals 5/2 would make it undefined. So that means x cannot equal 5/2, because if x did equal 5/2, then we would have 0 on the bottom of the fraction, and that's not possible. Example 2 says identify the asymptotes, domain, and range of the function. So starting with the asymptotes. The asymptotes are the lines that the graph cannot touch. So it looks like the vertical line that the graph cannot touch is running right through here. So it's very close to that line as we get close to the edge of the graph, but it cannot actually touch those lines. So that is the vertical asymptote. The vertical asymptote has an equation of x equal to positive 3, because every point along that line has the same x value, and that x value is positive 3. It also looks like the x-axis is another asymptote. It doesn't look like it's going to touch that. So that's in the form of y equals 0. That is the horizontal asymptote. Y equals 0 because every point on the x-axis has a y value equal to 0. Those are the asymptotes. And then we have to find the domain and the range. So the domain is going to be everything except for whatever that asymptote is. So the domain is going to be x cannot equal 3. See how it's based upon the asymptote. Since the asymptote is x equals 3, that's the line it can't touch. So that means x cannot equal 3. And the range is going to be y cannot equal 0. Again, based upon where the horizontal asymptote is. Since the horizontal asymptote is on the line y equals 0, and you cannot touch an asymptote as you approach infinity and negative infinity, the range is y cannot be 0. Part B, see, it looks like we have a vertical asymptote right through this line. So that is the line x equals negative 2. We have a horizontal asymptote right through here. That is the line y equals negative 1. So then the domain must be x cannot equal negative 2, and the range has to be y cannot equal negative 1.